This video shows the analysis of a simple circuit to derive the transfer function. So here you see our VI, which would be the transfer function. You can simplify this circuit a little bit by taking the Thevenin equivalent of this section of the circuit and redrawing for the Thevenin VTH equivalent versus an RTH. And then the rest of the circuit remains the same. I'm going to leave it in symbolic form. I'm changing the capacitor to 1 over CS for the analysis. So VTH is going to be this circuit with the voltage located here and nothing else connected to it on the right of it. So looking at that voltage at that node without anything connected to the right of it gives that VTH is a function of the input voltage VI. And then it's a voltage divider, so it's the voltage across R3, R1 plus R3. And RTH is the equivalent resistance seen at that same X node point, and since it's an independent source, the independent source gets shorted. And so I have R1 splits at that node, so R1 in parallel with R3. I just have a voltage divider. I'm finding V out at this location. So V out is going to be the voltage divider of VTH as the source, and then across R2 summing the rest of the impedances. So now I have a S in the bottom. Again, knowing that S is equal to j omega gives me a complex number on the bottom. What I want to do is always create the form of the transfer function to be either a number times S or the quantity of a number S plus 1. So because this isn't in that form, I'm going to multiply the top and the bottom by CS to get rid of that on the bottom. And now I have that form. I have on the top a number plus 1, or a number at times S, and then on the bottom I have the quantity of the number times S plus 1. So that is what I want. So now I can plug in the actual equations for VTH and RTH. And I get that V out is equal to R3, R2, CS, VI divided by R1 plus R3 R1 plus R3 times that quantity of R2 plus R1 in parallel with R3 times CS plus 1. And plugging in the numbers, this gives me the values of 133 nano, which is 10 to the 9th, times s, all over 266.7 nano s plus 1. And that concludes the derivation of the transfer function to get it into this form.